Good evening, ladies and gentlemen. Your host, Golden Zulu. So today we'll be looking at the differentiation of ln together with exponential functions, where if you have been faced with a function in ln where you are told to differentiate, the derivative of this function is the derivative of the function over the original function. So with us we have one example. So the first example here reads to say, find the derivative of ln ax plus b. So what you do here is, remember, this is the original function. So in this case, the original function is ax plus b. Then remember, in our previous videos, we said f prime is the function which is differentiated. So you will write this aside and you will differentiate this. You know to say the derivative of ax is a, and the derivative of b without any variable is 0. Let's assume b is a number. Then we get this and we put it here. So this is the derivative of this function there. The second one which we have been given is ln x squared minus 3x plus 1. So the first step, we'll just copy the original function. Remember, this is the original function. In this case, the original function is x squared minus 3x plus 1, where we will get it and put it aside so that we can differentiate it. So if you differentiate it, you will have 2x minus 3. So this is the derivative of this function. The third one which we have been faced with is ln sine 3x. So you will first copy the original function as the denominator, sine 3x. You know to say, if you were to get sine 3x, let us assume this 3x is u. You not say sine u, the derivative is what? Cos u. And remember we had assumed to say u is 3x. Then you differentiate 3x and you will have your function to be the derivative of what? 3. Where u in the first place is 3x, and we multiply this by 3. We are using chain rule for us to do the differentiation. So 3 times the one in front, you will have 3 cos 3x. Then this is the derivative of sine 3x. So get this and put it on top as your derivative here. Then we have another function which we have been faced with, x squared ln x. So we know to say that when you see two x's in one expression, we are using the product rule. You know to say the product rule is u prime v plus v prime u, where your u in this case is x squared and your u prime is 2x. Your v in this case is ln x and your v prime will be 1 over x. Then from here you just get this and replacing the formula. You know to say u prime is 2x and you know to say v is ln x plus v prime is 1 over x and u in this case is x squared. So from here this times that will give us 2x ln x plus x squared over x. Then the final answer will be 2x ln x plus x, because 1x here can cancel with the 2 there. Then our last example we have been faced with is the differentiation of ln x over x plus 1, where you know to say that this is a quotient rule you are going to use there. So the quotient rule here states that u prime v minus v prime u over v squared, where your u prime is ln x, your u is ln x and your u prime will be 1 over x. Your v will be x plus 1 and your v prime, you note the derivative of x is 1 and the derivative of 1 is 0. So from here we just start replacing. U prime in this case is 1 over x and your v is x plus 1. minus v prime is 1 while your u is ln x over the v squared. In this case it is x plus 1 squared, like this. Then what we will do now here is 1 times x is x plus 1 over x minus ln x over x plus 1 squared, like this. Then from here we'll say over 1, so that we have the common denominator, which is x. 1 times these, they're just the same, x plus 1 ln, then x times that is x ln x divided by x plus 1 squared, where you know to say that the division will go into a multiplicative sign, so you will have x plus 1 minus x ln, you have x ln x over x multiplied by 1 over x plus 1 squared, like this. Then from here you just multiply this with that, and you will have x plus 1 minus x ln x over x open bracket x plus 1 squared. So this is the derivative of that function. Your host, Golden Zulu.